Hello everyone, I'm going to be talking about our paper towards identifying impacted users in cellular services. Commercial cellular networks typically have customer service centers set up to handle feedback from users. When a user calls in with a technical problem, the agents run some standard technical tests and if necessary, they escalate the problem for investigation. As they do so, they write a summary of the user's problems, the troubleshooting steps taken, and their results. We define this agent-generated summary to be a case, and we'll define an event to be a service-impacting problem that affects multiple users, typically within a bounded geographic area. For example, a network outage, a device software bug, or a third-party server issue. If these cases could be mined, they would provide service operators the user's perspective of events. Such user perspective would provide a complementary viewpoint to that of standard service monitoring tools. When an event starts and impacted users start calling the customer service center, service operators want to learn of the event as soon as possible. However, each individual agent sees only a few cases about the event. They do not have the global picture. Each agent responds only to a tiny number of calls, and agents don't have time to discuss possible emerging events. Our problem is to identify the complete user perspective of an event with the few cases that an individual agent may be aware of. The problem of understanding user impact is naturally a machine learning problem, but the nature of the user feedback data makes it infeasible to directly apply standard techniques. The user feedback data comes from communication between the user and the agent, and there are many points for disparity in capturing the communication. Some differences come from variations in individual user and device behavior, while others come from variations in agent behavior. Moreover, users may not know when their device started misbehaving, so the times and locations of the problems they report may be only approximate. Another major challenge comes from the natural variation of language data. Two agents could speak to users with identical problems and still describe them very differently in the case notes. Inconsistent case handling by agents adds even more disparity. We have designed a practical framework called LOTUS for Location Trouble Scanner to identify the user perspective of an event addressing our specific challenges. With measurement analysis of the user feedback, we identify the unique characteristics of our data. On the basis of these characteristics, we develop a novel algorithmic framework to solve our problem that integrates co-training, spatial scan statistics, and deep sequence learning. LOTUS has been deployed since August 2018 in a field trial for care agent groups and operates in near real time.